Go.
Hello, my dear students, and welcome to my kitchen/office. It may also be our chemistry lab. I am going to quickly go over the assignment I gave you yesterday, and it's my goal by this time tomorrow at least to get a little video lecture rundown of this assignment, but it's rather long, and I don't want these to last long, so I'm going to do it in two parts. First page today, second page tomorrow, and then when I go back and revisit some of those problems you did, most of you did them great, maybe almost most. Half of you did them perfectly, and the other half either didn't do them, and I thank you for all the nice notes and everything. But let's get to our work. This is a nomenclature worksheet that you have, and it's a review of what we practiced when we walked around the lab and named those compounds. Only it's new compounds, and the question is, how do you know what to do and what rules of nomenclature do we use? And it's really, I hope I can show you, quite simple. So here's an unusual compound. It says, using the periodic table as a guide, predict the chemical formula, they spelled and wrong, and name of the compound formed by the following elements. And this is Ga. That doesn't stand for Georgia, that stands for gallium. It's in group 3A under aluminum, and like aluminum, it has a +3 charge. It's group 3, it has a +3 charge. If you're in the class right now, you look up over there at the periodic table and you see I wrote +3 above that column of elements because they always form +3 ions. Fluorine is group 7. It has 7 electrons. It wants to have 8. So what does it do? It picks up 1. It always forms a -1. So gallium is always +3 and fluorine is always -1. We don't write the 1. And actually, I'm supposed to write this the new way, 3+. And fluorine is 1-. The 1 is understood. But here's the deal. When we put gallium and fluorine together, we form a new compound. And the new compound must be electrically neutral. So we have 3 pluses and 1-. So we make a new compound, gallium fluoride, with 3 fluorines. And we call it gallium fluoride. We change the fluorine to end in "ide." Okay? Now, so that's how we're going to go. I'm going to go through these quickly and answer them for you, showing you how to do it. Lithium is group 1. It's always +1. Hydrogen can be +1 or -1. In this case, though, we're forming the minus hydrogen ion. So we form this compound, lithium hydride, LiH. Lithium hydride. You might want to zoom in on those names or just make sure that they're clear to the students. So aluminum, like gallium, is group 3. It's always +3. Iodine, like fluorine, is a halogen. And so it's in group 7. It always forms a -1 ion. Look up there on that thin periodic table of the elements, and you'll see at the top of the row, I wrote -1. So it's group 7. It has 7 electrons. It wants to have 8. It picks up 1 electron and always is a minus. So again, like here, we form aluminum iodide, I3. We don't have to say triiodide because this is the only configuration. Those will go together to form a neutral species. We name the metal first, aluminum in America. The English say aluminium. They still spell it the same, so go figure that. But aluminum iodide, we change the ending to "ide." Aluminum iodide. The next one is potassium. It's group 1, capital K. So it always forms a 1+ ion. Sulfur is group 6 right there under oxygen. It has 6 electrons. It wants to have 8, so it picks up 2. 2 negatively charged electrons. So it forms a -2. So we write that 2 minus. So I need 2 potassiums per sulfur. And again, we change the N to I. We name the metal first, potassium iodide. Okay? If I may go back and divulge briefly, hydrogen, if you look at the chart, it says over here it can form a +1 or a -1 in your Flynn periodic table of the elements. So it can form a +1 or a -1. In this case, it formed a -1 to form the hydride. Now, here's calcium and bromine. Calcium's a group 2 metal, an alkali earth metal, group 2A, so it forms a 2+ ion. Has 2 electrons. It's not going to pick up 6 to form 8. So it gives up 2 in its outer shell, takes it down to its next shell, which is a filled shell with 8 electrons in it. So it's happy as a 2+ ion. Bromine, group 7, forms a minus. 2+, 1 minus. I'm going to form calcium bromide with 2 bromines per calcium, so I can have an overall net neutral charge. And this, of course, is called calcium bromide. And I hope you remember, half of the world's supply, actually it's about a fourth now, comes from Arkansas. Half the world's supply of bromine. You just watch those tank cars rolling by in Duma sometimes. You'll see whole freight trains of these giant tank cars with thousands and thousands of liters of liquid bromine in them, coming from down around Smackover, from down around El Dorado, from a little town called Smackover, which supplies much of the world with bromine. This next one says CO3. That's a polyatomic ion. It's actually called carbonate. And if you look on your table or into a table of the polyatomic ions, the common polyatomic ions, I gave you a copy of that table. I can get some more and make sure everybody has one. You'll see it's listed with a 2- charge. Potassium's group 1. It always has a +1 charge. We already established that here. So this is 2 potassiums, 1 carbonate anion with a 2- polyatomic ion. And this is called potassium. The element symbol is K from the Latin kalium. You will still see that. Those of you going into the medical field may hear hyperkalemia, which means too high a potassium in your blood, or hypokalemuria, which is, kalium in the urine. So you're excreting too much potassium. Both those are problems, but they still use that term instead of high potassium and low potassium. They say hypo and hyperkalemia in the blood. Potassium carbonate. I meant to write that in red, but you get the idea. Okay? So, 3 more for that first one. Let's get them done and get them out of the way. So, get rid of my sheet here and pick up my pens again. And look at these others. So this is aluminum, again, +3, and you would have no idea what this is. This is CH3. It structurally looks like this, with 2 O's, one like this and one like that. That's the acetate anion. If I put an H here to neutralize that, it's acetic acid. So this is called acetate, and it has a -1 charge, so I would have aluminum, parenthetically, C2H3O, 3 of those, because each one's a -1 and this is a +3. And I would name this simply aluminum acetate. You would get it by, for example, putting aluminum into acetic acid and letting it slowly, it would happen slowly, form aluminum acetate. The next one, it doesn't have the charges, but I went ahead and put them up. It's two polyatomic ions, a positive one called ammonium. Now, NH3 is ammonia gas, but when you add a plus 1 hydrogen to it, you get NH4 plus 1, and that is ammonium. And sulfate has a 2 minus charge. You can see that on your table of the polyatomic ions. So I need 2 of these per one of these. And we name the cation first, the anion second. And this is a very common laboratory compound, ammonium sulfate. Spelled with an F in America, not a PH. And this is also a very common fertilizer. You can buy 50-pound sacks of it. Fairly cheap to make. This next one had magnesium. Magnesium's group 2, it's always plus 2. Phosphate is a polyatomic ion. It's 3 minus. If you add 3 hydrogens to it, you make phosphoric acid. But I'm going to make magnesium phosphate. Uh-oh, I got a plus 2 and a 3 minus. How am I going to put those together? Well, crisscross. I need 3 of these and 2 of these. So if I have 3 magnesium in my magnesium phosphate, then I need 2 of these, because this would be 2 plus times 3 or plus 6. And my phosphate, I need 2 of them, so we bracket it with parentheses and put a 2 there. Would be 2 times minus 3. I have minus 6 and plus 6. I now have a neutral species for my compound known as magnesium phosphate. Now, let's do these other 2 real fast. One is, given the formula, give me the name. That's just like we did in the lab. And you know what? I would say go to that lab, but I have it right here at home. I need to send you my graded labs back to you. I'll try and do that. If not today, I will do it tomorrow. Those had also in the lab a chart of the polyatomic ions as well. But you've already practiced doing this, so let's do this as quickly as we can for question 2. So the first one is A is LiNO3. That is, in red, the correct answer, lithium nitrate. Wonderful oxidizer and explosive for fireworks. Gives a brilliant scarlet color, red color when it explodes in fireworks. The next one is SC. We don't see it very often. SC2O3, and this is scandium, one of the Scandinavian ones. Scandium oxide. Oxygen, change it to the ide. Okay, C, just by way of doing this, is cesium. Oops. Big C, little s with the bromine. Big B, little r. And this is this compound, cesium bromide. I should also say in international books, they spell cesium C-A-E or C-E-A. They put an A in there in the classic British style. So let's go on to D and see if we can get through these quickly. Is NF3. Fluorine is group 7. Always is -1. Nitrogen's group 5. Is very frequently. It has all kinds of valences, but +3, so you get this nitrogen with 3 fluorines, but this is just nitrogen fluoride. Okay, for E, we're going through this. Ag2, silver is always +1, so you don't have to write it down. AgSO4. So when you write this, even though it's a transition metal, you don't need to put the Roman numeral 1 in parentheses because silver is one of the weird ones. No one would fault you if you did, though. Silver is one of the few transition metals, like zinc is the other common one, that doesn't have multiple valences. So you don't need to include the Roman numeral 1 there. And it is silver sulfate. F is PF5. Ooh, that's a fun one. Has a very interesting geometry. This is 2 non-metals. So now we do need to use our Greek prefaces or prefixes. So this is phosphorus. I'm going to start over here because I don't have enough room. Penta for 5, fluoride. If you look, phosphorus and fluorine are both to the right of the step line, which means they're both nonmetals. So we're forming a covalent compound here. EFG is NaI, a very common salt. You've probably had it because anytime you put salt on something, you either put Ni or Ki on it. And this is sodium iodide. And if you add it to normal table salt sodium chloride, you call it iodized salt. You also use, and even more commonly, the potassium iodide. Also, if nuclear war breaks out, this is a good thing to eat to displace the radioactive iodine that can cause cancer of your thyroid, which accumulates iodine. Just thinking of current events here. Let's do H and then move on to a new page. Is SCl2. Again, 2 nonmetals, so I have to use my Greek prefixes. Sulfur dichloride. Okay? 2 chlorines per 1 sulfur. And they gave you that information. May not bury my periodic table because I'm going to need it. Okay. 4 more for this question, then we'll do the last question. We're done. I is CaNO3 and this is simply calcium. Always has a +2 charge, and nitrate always has a -1, so you need 2 of them. But this is a polyatomic ion, and to show that they stay together, we write the nitrate -1 anion parenthetically. Nitrate. And JK, right? JKL. J is FeCl3. K is CoCO3. And L, little l, is N2O4. This one is iron, but iron can be +2 or +3. This one is obviously the +3 because it's got 3 chlorine -1s. Chlorine is always -1. It's a group 7. It has 7 electrons. At 1 step 8, it picks up 1. It picks up 1 per chlorine atom, but iron can be a +2 or a +3. To designate this iron chloride from the FeCl2 form, we write the charge here. CHLORIDE. Iron 3 chloride is its formal name. In the old days, we said ferric and ferrous chloride. We don't use that terminology anymore. This is great because it always tells you the charge on the iron. Cobalt is also a transition metal, and it has multiple valences. And let's see how they wrote this that way. So this is cobalt carbonate, but cobalt can be +1 or +2, as I remember. You can look on your periodic table and it will tell you. But this one is definitely 2 because carbonate's always -2, and there's a 1-to-1 correspondence, equal molar ratio between the cobalt and the carbonate anion. So this is cobalt 2 carbonate. And finally, this is a tough one in the sense that, boy, the oxides of nitrogen, NO2, NO, N2O2, the nitrous oxides and everything are very complicated. The formal name for this one is, a lot of people just say nitrogen oxide, but nitrogen, dinitrogen, do it in all caps, dinitrogen tetroxide. If you wrote tetraoxide, you'd be okay too, but when you have an element starting with a vowel, you usually drop the A. But if you said tetraoxide, no one would fault you. That's your answer. Let's go on to the next and last question and do this real fast. So, question 3, and then I'll work the ones on the back in a succeeding video. Aluminum, they spelled it wrong, hydroxide. Write the chemical formula as Fro. They meant 4. Boy, they should have had me edit this and correct these. For the following compounds. Aluminum hydroxide. Aluminum is always +3. And so, I'm not going to write it down. It's Al. OH is always -1. I need 3 of those. Okay? So A, B, C, D, E, F. And let's see if we can go over here. G, H, I, J, K, and we'll be done. The next one says potassium sulfate. Look on your table of the polyatomic ions. I will never make you take a test without that. Sulfate is always 2-, so it's K2SO4. Sounds like a droid from Rogue One. K2SO4. Copper 1 oxide. That means the copper has a +1 charge with that Roman numeral 1. Oxides are always -2, so this is Cu2O. Oxygen's always -2. It's group 6, always -2. The next one is zinc nitrate. So zinc is always +2. Nitrate is always -1. So I need 2 nitrates per zinc. Zinc is a transition metal, and you could write Roman numeral 2, but like silver, it's one of the ones that doesn't have multiple valences. No one would fault you if you did write Zn, parenthetically too, but they didn't do it here. So mercury 2 bromide. So that means the mercury has a +2 charge. Mercury is Hg, and I need 2 of the -1 bromines. HgBr2 is your answer. Iron 3 carbonate. There's that iron 3 again. So this is going to be Fe. Carbonate is always -2. This is +3. So I'm going to need 2 of these. And for my carbonates, I'm going to need 3. Fe2, parenthetically, CO2, 3. Okay, quickly. The next one is sodium phosphate. Phosphate is one of the, it's a big polyatomic anion. It has a -3 charge. So if I have sodium, Na3PO4. Okay, you don't need parentheses because I just have one of those. This is, by the way, also sold as TSP or trisodium phosphate at Lowe's and paint and hardware stores for cleaning surfaces and preparing them before you paint. Cobalt 2 nitrate. Cobalt is a +2, nitrate is a -1. Just look it up in the table and do it too. I want to diverge and go back very quickly. For these nitrogen compounds, I get so confused myself. I can deal with the official IUPAC, International Union of Pure and Applied Chemistry name very well. But they all have trivial names that are in such common usage that if you're in any doubt, you need to just Google it or look it up in a chemistry textbook. Anyway, copper 2 perchlorate. Copper is a +2. The perchlorate ion is a -1. And the perchlorate, chlorate is ClO3, and perchlorate means it has an extra oxygen, ClO4. And it is a -1, so I need 2 of those. And the last two, magnesium hydrogen carbonate. Magnesium is group 2, it's always +2. Hydrogen carbonate, also formerly known as bicarbonate. When I took freshman chemistry in 1972, not just before you were born, but before your parents were born, it was called magnesium bicarbonate. You still buy sodium bicarbonate or bicarbonate of soda at the store, but technically it's sodium hydrogen carbonate now. It changed actually that year. So it's been 50 years since it's changed. Anyway, it's HCO3. CO3 is usually -2, like this one up here, but with the hydrogen it becomes -1, so I need 2 of those. And last but not least, chromium 3 acetate, Cr, has a +3 charge, so I'm going to need C2H4O2-. It said chromium 3, I'm going to need 3 of those. So that's my acetate that we talked about earlier. That finishes this first page that I assigned you yesterday and promised I would be getting some videos out. I'm doing them now. I'm going to do 2 more and post those, maybe 1 a day. I'm not going to overload you with them, and get these other ones done. Goodbye now, and stay safe.